Hello. This video is the first video in my series of differentiation videos where I'm basically going to be working out the derivatives of many different functions. In this first video, we're going to start with probably the easiest of the lot, or the most basic of the lot, and that's to find. Sorry, let me write that again. So to find the derivative of x to the power of n with respect to x. So in other words, what we want to work out is we want to work out this. So yeah, the derivative of x to the power of n, where n is just a real number, and x is also a real number as well, a real variable. So to do this, then what we're going to do is use the definition of what a derivative is. So let's just remind ourselves of that definition. So yeah, the derivative of f of x is defined by this. So the derivative is the limit as h goes to 0 of f of x plus h minus f of x divided by h. So that's our definition that we're going to use, and we're going to use that to work out the derivative of x to the power of n. So if we go on to the next page, then, so if we let f of x equal x to the power of m, then what does that mean? So that means that f of x plus h is going to be equal to x plus h to the power of m. So just swapping the x with the x plus h as a replacement, and then we can use our definition to find the derivative. So the derivative of x to the power of n is going to be the limit as h goes to 0 of f of x plus h. So using this formula, or this definition down here, f of x plus h is going to be x plus h to the power of m, and then subtract f of x, which is just x to the power of m, and then divide by h. So now the next step in this process is going to be to expand the brackets here. So this x plus h all to the power of n. And the easiest way to do that is just to use a binomial expansion, or to use the binomial expansion to expand those brackets. So we've got the limit as h goes to 0, and then expanding these brackets using the binomial expansion. That's going to be x to the power of m plus, technically n choose 1, multiplied by x to the power of n minus 1, multiplied by h, and then plus n choose 2, x to the power of n minus 2 times h to the power of 2, and then so on and so on and so on until we just get to h to the power of n. So that's our binomial expansion done for the first term. And then we've got this take away x to the power of n as well at the end there. And this is all divided by h. So now we can actually cancel out a little bit at the top. We've got this x to the power of n here, and this minus x to the power of n, so that can cancel out. And then we can kind of simplify this a little bit. Just make my writing a bit smaller. So we can simplify the fraction now. So we've got the limit as h goes to 0. I mean, we can actually factorize the h's out on the top. So you've got an h there, we've got an h squared there, an h to the n there, and all these h's in between there. So we can just factorize out, or factor out the h's. So we've got h there, multiplied by n choose 1, which is just n. So I'll just write an n there. So n times x to the power of n plus n choose 2, x to the power of n minus 2 times h, and plus all of these other numbers, plus h to the power of n minus 1. So I've just factorized out the h on the top of the fraction, and then divide that by h on the bottom. And as you can see, we can cancel out the h there and the h there. And so what we're going to be left with, again, if I just make my writing a bit smaller, we're going to be left with the limit as h goes to 0 of n x to the power of n minus 1 plus n choose 2 x to the power of n minus 2 multiplied by h, and then plus all these other terms, and then plus h to the power of n minus 1. Now, okay, so we've got no h's in this first term here, so we don't need to worry about this limit as h goes to 0 with respect to this first term, because you've got no h's there, so that's kind of irrelevant in this case. The limit as h goes to 0 of this term here, but as h goes to 0, this term here is just going to literally go to 0 itself. So that's going to become 0. And so all these other terms in the middle here, because they have h squared, h cubed, h to the 4, and so on, multiplied by each respective term. So as h goes to 0, all these terms will be 0. And obviously h to the power of n minus 1, as h goes to 0, this number here is going to go to 0 too. So that becomes 0. And so we're just left with this first term here, and we're going to just get n multiplied by x to the power of n minus 1. And that's the final answer. So what we know then is that when we differentiate x to the power of m with respect to x, we're going to get n multiplied by x to the power of n minus 1. And you probably would have seen this. I mean, you would have seen this before if you've done differentiation before, because obviously if you differentiate something like this, the derivative of x squared, that's just going to be 2x. You would have seen this rule where you bring the power to the front and take away 1 from the power. That's probably what you've been taught in school or class. And this here is a proof of why that is true. So we've just proved that this result is true for n being a real number and x being a real variable.